All right, what's up, everyone? Sorry I got a little sidetracked at the end of the recording there yesterday, and I'm gonna pick this back up where we were. Okay, so you probably don't need a recap, but I kind of do. So let's see. So we had our model and our data set up, and we were about to start writing our training loop. I had just kind of walked through getting a model instantiation up and running, and showing how that worked. But we actually are going to maybe come at this a different way. So I'm going to go back to the data exploration part just so I can grab that URL again. Because remember, we passed that into the data set. When we first get started. I'm also going to grab these two lines and then probably one more. But we shouldn't need the data set, but we still do need the data loader just because of how I set that up. And then I'll grab these two lines of code. And then we'll be able to actually get started in earnest. Okay. I'm going to pull this out. Leave that at 4 for now. But I do want to leave that as a configurable thing. I'm just going to bump this up to 2 for convenience at the moment. We'll see if that's actually necessary. So I'm going to get rid of that. We're going to need that going, got this going, maybe cannot import GF. Oh yeah, I did a bad job pasting. Okay, so we're good on there, good on that. And then this is going to be, and you know what, actually DS, let me just really quickly. So what we kind of really want to do here is split out our train, test, and validation splits. This data set is really big, so I don't know if I necessarily want to just do it all contiguous, because for the sake of this tutorial, I don't know if I'm going to be able to, like, in real time train a full model. So let's just do... yeah, we'll keep it very small for this second. Oh, yeah, that's not, that code is incorrect. See, you can't really trust Copilot to make good inferences about your own code even. So that goes to show you still need to know what you're doing. So here we go. We got the input times. Okay, so train time steps, do valid time steps, and then test. And we won't use the test time steps for the moment. So, and let's actually do this a little bit. Good. And see, this is where it actually does work. And I would normally split this out into something a little bit more legible, but that's fine for now. Okay, so we're going to put together all of those data sets. Train D is going to be FS data set, and that's going to be train DS, and we'll still do, I was doing 5 and 2, and then we'll leave the temperature as our variable. Okay, yep. And these are going to have to be the same between all of these, so just be aware of that. And I'm just setting these, again, to be some small number just for the sake of getting this set up. Ooh, like train loader. Yeah, there we go. Man, we are not going to have 32 batches. Yeah, maybe I'll make this 240. That's still going to be... And they don't have to, and usually aren't of equal size. I'm just doing that again for the ease of writing it out at the moment. Okay, we need a valid loader as well, and we'll keep that the same. Okay, so we've got our data pipeline set up. We now need our model, and that's going to be a ResNet. And let's go back over to the model definition there, just you know, because it's been a couple, you know, bit too long for me. So it needs 5 input channels, and we're outputting 2 output channels, which in this case are the time steps. Activation, I think is fine. I think everything else is fine. We'll allow it. Nice. That's nice and clean. Oh wait, that's just double conf. We need more. We need more. Here we go. We need a hidden dimension. I'll hit it with a good classic 64 and a depth of 2. And you know what? Just because this is, and I should do this with the other thing too. In channels equals. This just makes it more legible. So check that out. We've got ourselves a model. We've got our project thing, then we've got that, and then we've got a nice double conv in here. So one thing that I was reflecting on is I probably should make this not depth -1, but just depth, and I'm going to have to clear and restart my kernel to do this, because originally I was counting these as part of the depth, which it's technically true, but it might be a little misleading. So the depth is only going to refer to the residual blocks. So just a minor change that I was thinking about that I wanted to make. Okay, great. Then model dot so I don't have torch imported. Okay, good. So now let's see what we got here. We got a ResNet going on. We're going to put it on the GPU. In my case, I'm just going to double check here. Let's see. So 2 of the GPUs are currently being used on my machine, so I'm just going to use GPU 005. Good. So that's now up and running. Now, def train epoch. This is where we're going to need to do some stuff. And it does basically look like that. Let's see. I think, actually, let's develop this outside of the function first, just so you can see me do it sort of iteratively. So I know I'm going to need to do 4 I gotta turn this off again, but yeah, let's go ahead and start there. And I think that's adding the I is nice. In enumerate train deal. No, train loader. X equals x dot 2, and you know, let's just do model dot device. Is it model? Is it an instance? Oh, model dot. Well, we can just do. Let's configure this out. I'll start putting all the config stuff up here. So device equals boop. Good. You'll note I'm rerunning a lot of stuff over and over again, so you gotta be careful not to mess up our state. But I feel good about this. So the first thing we're gonna do is the data loader is gonna go ahead and grab our stuff, but it's not going to be on the GPU. So we need to put it on the GPU first, and you can do that with that command. One other thing to note, this is float 32, the data DS also, you'll see that its default was float 32. You might need to do some conversion there for your own data, but make sure your data types are all the same. Okay, and then you can run your model, and I'm just going to add in a break. And this will probably take, I think it said 20 seconds, so I'm going to pause for a moment. Hey, where'd my little recording things go? Move this, where did it go? Ah, it doesn't come along with me. Okay. Okay, actually, I'm going to go back here. I'm going to redo some stuff, or I sort of did. I bumped up the number of workers, and I do want this to be smaller for right now. We're going to have to do some data loading, tuning to get that speed up in a little bit, but I just want to show that this is actually working and we can run our model. Note, it's not trained, so it's going to like produce garbage. And sorry, my camera's like having trouble getting, there you go. Okay, so anyway, now we're running, and I really should have put a print, well, it's okay, that's fine. And we can go over to our dashboard as before, and we can see it's doing its thing. It's now able to get these out pretty quickly. And I hope that this doesn't take too long. Should not take a batch size of 8. Wonder what the chunking is like on this guy. That might be part of it. Oh, I guess it did get through. Okay, cool. In 45 seconds, that's not great. Yeah, let me look at the chunking here. Okay, yeah. So I should probably... Oh, we'll come back to this. Okay. Delete that for now. So we got that to run. We did run our model, and this is the thing that I really, I always sort of start with, is just running the model and making sure that the shape of what comes in and or out of the model is the same as the other, as the actual data. So let me pause. Okay, so anyway, the shapes are the same. That means we can calculate the loss function and do the optimization, right? So that's what we really wanted to double check. So, okay, now, as I mentioned, we need a loss function and an optimization routine. So we're going to go ahead and get those started. I'm just going to call it, pretty standard stuff. Opt is torch dot, and then, is it .nn.atom? Wait, how do I? Optim, sorry. I've been out of this for a little bit. And I always use atom W, which has some regularization built in. The regular atom you can get to do weight decay in the same way, but this is just for the sake of getting it for free. We'll need a learning rate. 20 -3 is usually a good starting point. Yeah, I know. I'm done writing that. So you always pass your model's parameters and it's LR, yeah. Okay, so those are the two things you need there, and then loss fn is torch dot. We'll do mean squared error loss. As this is a regression problem, that usually works pretty good for you. And so then what you're going to need to do for this is you'll run this, and we'll need to opt.0. So basically this is resetting the gradient. there are ways that you can do this to do like multi-step optimization or gradient accumulation, but we're just doing the standard way. So that's why you always have to remember to zero your gradients. That way you don't sort of accumulate them and it'll lead to model divergence. So loss equals loss fn of y comma y hat. No, I'm not using that. And then loss dot backwards. So that's calculating, doing the back prop thing. And then opt dot step. So you've calculated, back propagation is how you calculate the gradients, and then you walk in the direction of the gradients more or less. So that's a training routine right there. So I'll just go ahead and get this a print loss, and then I want to do one other thing. And I know we're going to have to tmux a dash t, I think it was 6. Yeah, so, okay, cool. So again, we're back here. I've never noticed AIO, happy eyeballs, interesting package name. But I also want to import, let's do from tqdm auto notebook import tqdm. So tqdm is a nice little thing for making progress bars, and so obviously it's not installed, so we're going to have to go back over here, uv not init add tqdm, get that going on. Okay, we're back in business, restart, clear it all out, grab up to where we were, and so now you'll note that this is going to make a little progress bar. Oh, I didn't write the code to actually do it. So I'll leave the I and enumerate on there, but I don't really need to. But you just wrap whatever the thing you are iterating over in your loop. And I think we wrote the data set as a map one, so it does have a length. So we could definitely also pre-calculate some stuff. Oh, I should also, I'm going to grab this batch size and this batch size, and then I'll put this up in the config section. Cool. So we get that up there. And then what was I going to do? Oh, I needed to, I wanted, I didn't need to, but I would like to calculate the train samples, I should use n train samples, and that's going to be equal to len of train d divided by batch size. Parentheses, well, we'll leave that one up. And I believe, I don't think that the data loader produces uneven batch sizes, so I think we have to round it down to the nearest int. Okay, cool. Oh, not just valid, it's valid underscore d. Okay, cool. And note, I'm doing it on this thing here because once you put it into a data loader, it kind of loses some of that introspection capability. So that's where we'll calculate it, the length explicitly as the number of samples divided by the number of samples in a batch. So that's what that's doing. And this is taking extremely long again. Let's jump back over here and see what's up. Did I somehow get myself rate limited? Well, I can't have lost the connection because I'm SSH'd in and I'm not on campus, so. Okay, so I definitely didn't lose a connection, that's fine. I think Dynamical may have shut me down. I'm gonna get rid of that for a second. And then I'm gonna do show, I think. So I'm able to get the data out. That wasn't too bad. I wonder why they didn't let me. Okay, let's just see what happens. I don't have access to the dashboard because I got rid of the client here, but I don't think I have IOTop on this. Well, just see if it goes through. I can at least go NBTop and see. Yeah, so I'm doing stuff with the CPU here. So I think it's running something. I think before it took like 48 seconds, so let's just see. I'll let it go for another 20 seconds or so. Oh. Backward, I think. Yeah, okay. I just typoed that a little bit. I gotta get that going. But, okay, so we got 48 seconds. That's good. That's actually using a decent amount of GPU memory. Why is that? Oh, right, because it's 1440. Yeah, it's a big image. So maybe that's something that I could actually prototype the model with a smaller piece. Yeah, let's do that. So I will also get out of NBTop there. Okay. Yeah, for the sake of training, let's just grab a small section. So I'm actually going to split this cell and then do let's see. DS dot cell. Yeah, I restarted it. Okay, cool. So I think I'm gonna be totally American here and just pull out most of North America. So that's, let's see, how is this ordered? Negative, okay. ds dot cell lat equals slice. So we want latitudes. Let's go 25 to 50. Keep it nice and simple. And and it's not it's latitude. And then we're going to go negative 130 to negative 45. And do that. No numeric data to plot. It's probably an ordering thing. See, this is what I was looking for. DS. Oh, yeah, latitude. So it was the other way around on latitude. Okay. Open up the data again. I shouldn't need that this time. And now this time we should see. Ooh, aspect ratio is a bit off, but this looks good. And let's just see what we've done here. Yeah, so now it's 100 by 300. This is going to be a significantly better in terms of speed. But I'm going to make a note. Fix data set speed and return to float. Okay, great. That's gonna be better. Let's just see how that is. I mean, it's still not going to be probably as fast as we want, but it should be. Yeah. Okay, I can work with that. Okay, so now what I know I also want to add in here, and I'm going to go back over to this. I'm going to pause for a second. And then what I want to look at, and there we go. So TQDM takes this total. Oh, I probably could have found that there. And that's going to be n train samples. And now when I hit this, now you'll see, okay, so it should really be batches, huh? Not samples. Let's fix that. You might, if you're still somewhat new to coding, you might be going like, but the code worked. Why go back and change that? This is the sort of thing that you should really do feature you a solid, and when you notice that the name of a variable isn't exactly what it is actually referencing, go back and change it right away. Otherwise, you're just setting yourself up for confusion. Okay, so now what I want to do, this is sort of what I would call your scaffold for a single epoch. And this is where you'll start doing things like adding in those that logging, and we're going to put this in here, and I put it in a function called train epoch for a couple of reasons. First off is, and I missed the little thing. We'll get there. So first off is, I don't know, when you get your code like really deep in loops, it can be kind of hard to see. You're losing a huge amount of horizontal space, and that's why some people will use two spaces as indent, or if you're absolutely a madman, you might use one space for an indent, which is technically legal Python, but I prefer the standard 4, and so yeah, you just end up losing a lot of horizontal space. And then you can't have like two editors open. I know I'm like almost never jumping over here, but it's still nice to have it. So that's why I do that. I'm just going to return the mean of all of the batches as the loss. Okay, get that in there. Oh, I'm going to have to rerun that. Okay, cool. Now it's imported. So this thing obviously needs some inputs now, right? Like it's not going to know what train loader is, and it's not going to know what all of this junk is about the model, the optimizer, and the loss function. So this is pretty standard to put these in here. The thing that I do also, I'm just going to upfront refactor something, but first get that initialized. I'm going to refactor something real quick, because we're going to use this for both training and validation. So it's going to be n batches and n just loader, because I don't necessarily know if I'm going to be training or validating. So let's go ahead, model loader, and I like to keep sort of all of like the big objects up front. So that's that, and then loss fn device. And then we'll have n batches. So now we're getting to the smaller sort of like, that's just a number or whatever. And then the last thing that I want to set in here is train equals true. And then here, basically what I'm going to do is, let me make sure I get this right. I think it's just here. If Oh, it's not right there. If train, then with, oh, wait. No matter what, we want to calculate that. So the only thing we want to do when we always want to run the model, but I'm just trying to think through the best way to structure this. We can just do it this way. Otherwise, else, and this to be explicit here, so we're not actually updating the model parameters. We still want to run the model and calculate the loss, but we don't want to do this this backwards in the optimization step. So we just need these two things. But then we do need one other minor thing, and that's going to be like with torch.nograd. And that's sort of a context thing as well. Cool. So all that does is it means that you aren't running the, you aren't keeping track of the gradients anymore for just that window inside of the with torch nograd. So then it just minorly speeds things up. It's not critical, but you know, in the scheme of things, it's nice to have set up. I'm going to leave the break in there, but the break has to go inside of, okay. And I'm going to, just for right now, do that. So right, what an epoch would do in a general sense is loop over all of your data, train until you reach the end of the data, and that's one epoch, right? That's getting through the whole thing. So then what you might have is def train model. Okay, let's see here. Not a semicolon. We're going to need to, you know, kind of pass all of these things in. So I think it's going to be easier to explain some of this if we actually write it all out first. So let's go with that. Okay, anyway, back after a quick distraction. But here we go. So we're building the train model. And I think that's about it. And this is basically just a pass through. So we're gonna do like and I remember what I was sort of fussing over here. So I'm actually gonna take that out. So I'm gonna make it so that we can go through the validation loader here. Only if it's provided. And let's do and now this is basically going to just be a very simple pass-through loop. So for now, for in. So we're just going to loop over the maximum total epochs, and then I'm going to do train epoch. And I'm going to put all my junk in here. So model, loader, opt, loss, device, and train, and batches. See, this is one of those where there's probably a better way to do this, but I'd rather have, so then, okay. Okay, and I leave these defaulted because you might not want to do it. You might just want to only do training, so it's an option for you. Keeps the code flexible. So next up we need to do, and no, it's now going to be train batches. Remember, if valid loader is not none, then we'll also do, oh, and this is going to return, I'll call that that. Okay, so that's all that's going to do. Do I want to print out? For now, this will be fine. Usually it's nice when you can add like a little piece to the status bar that will tell you like what the current stats are, but no biggie. Return train loss valid. Keep making that typo. Okay. So that's good. That's all nice. I'm gonna assume that works. And now we're gonna go back into here, back in our source. I'll go new file, train.py, easy. Put it back over here. So all of our main library code is getting stored over here. And we're gonna need to do our imports. I'm just gonna grab this here. Okay, import torch. I know we're gonna need that. Import, oh, this is gonna be faster. And what else are we missing? I think everything else comes in from, yeah, okay, cool. So, no, I still have to, fix that in a minute, but I want to I'm gonna do this as well. I'm gonna just organize my code a little bit, and then I'm gonna do from source.train import this train model. Okay. Did I define max epochs up here? No. Go to 10. So now, remember, I haven't changed this. So the thing that I'm doing right now is something that I often do. This is going to, on train epoch, all this is going to do is run one batch, and then it's always going to quit out. Fix this real quick. So basically what I'm doing here is really trying to overfit on a single batch. And yeah, and I really like this advice from this talk from Andrej Karpathy, who has this really nice article just aligning some of the like things that you should really be good at and have a nice sort of intuition around. So again here, like this is where we're at kind of, and yeah, so that's kind of what he says, is go ahead and make sure that your model can learn, because if at this point you can't fit on a single batch, you probably have done something wrong. So let's find out if I did. Clear that and that. Okay, so I've got everything defined, and next up, I just need to run train model, right? And that's going to return train loss valid loss equals train model. And we're gonna do that model. Finally, okay, so this is going to take a while, right? And actually, so I'm going to get rid of this TQDM in here. No, I'm not. I'm going to leave it in there. I don't feel like restarting everything, but well, you know, I just meant so it doesn't just show double. But okay, so we'll let this do its thing. It's going to take a little bit because we're still unoptimized there. And now you can see it's, yeah, this is part of why I was going to take it out originally. Anyhow, I'll pause this and be back in a couple minutes. Cool, so we're back. That actually took a little bit longer than anticipated, but you know, that's how it normally goes. Had a few batches in here that took significantly longer than the others. But I took a little bit of that time to try and, I think this might fix that where it, you know, is like spamming us with each individual epoch for both train and validation is spamming us with a new bar. But let's go ahead and not all loss, train loss, and thought I had that. Okay, get that in there. All right, let's just take a look at what happened. Yeah, okay, so good. Is interesting. We did start to see some jaggediness, and you know, at this point, this is a pretty solid looking thing. Those are pretty small loss numbers, to be honest. I think it's probably a result of how we did this. Anyway, okay, so next up, so I just want to talk about a few things. So this is all working. You've got yourself basically through to the training routine. I'm probably not going to cover the whole inference and model saving and all of that in this video because I thought this was going to take me 1 hour to actually run through, but here we are. Typical, I guess. But maybe I'm going to point you to something in here, and this is geo. Yeah. So I'm going to take you to one of my other tutorial things. Let me go to the actual thing. So this is part of the GeoSmart project, and it has all kinds of, they call them use case books, but they're essentially little Jupyter books. So this is one that I wrote for using LSTMs to predict future snow. But the thing that I want to highlight, so kind of where we're at is, so it kind of follows a similar path. Data, implementing a model and training pipeline. So we're kind of at the bottom of this in here. And the part that I want to really just highlight for you is that I have this section, a very light introduction to ML Ops. So this ML Ops is like machine learning operations. So it essentially is how you go and you actually can set yourself up with some nice code infrastructure, I guess, for configuring experiments and saving them, loading them, and then that means you can essentially do all of your training, save your experiment, come back to it, load your config, and then, for example, you know, run it on a new data set and get some predictions out. So just to highlight that, check it out. It's trying to hit back button here. Oh, different tab. That explains it. Yeah, so just check it out, geosmart.github.io, right there. It's under use cases. Oh, going the wrong way. Okay, so back at it. We got a good sort of loss thing. I know we are currently still dealing with the data loading being slow. I think I kind of want to sidestep that, to be honest. I'm going to see DS, and I just want to look. DS, I'm going to keep it consistent in bytes. What are we at? It's only a 12 gigabyte data set. I think we can just load this. We're going to sidestep a lot of that training speed issue that way. Okay, so I don't necessarily recommend doing this all the time, but if we're just going to train on the US portion, I think it's fine. For, this is a tutorial, we can work with it. So as I mentioned, this machine has way more memory. This has a terabyte of memory. Like this is a big machine, so it can definitely take this. This is right about where your laptop could probably handle. And I think Google Colab is usually, I think it's 16 or 24-ish gigabytes of memory that they give you. Anyhow, and I don't know exactly how big their GPUs are anyway, so I'm going to get rid of that. We're just going to go for it. Yeah, and that's the full, sorry, I just need to look. Yeah, that's the full 82,000 time steps. So, okay, I still think that we don't even want to do that for this, because I'm just thinking about it. Let's see, it's hourly. Let's say, and I know we've got to be a little bit careful here, because like the annual piece or whatever. What if we resampled it to daily means? I'm just trying to think through, like, what's a good way to... Yeah, let's resample it to daily means. So, okay. Yeah. And then the other thing... Okay, so I'm going to add one more thing. From... I need to look this up. Oh, there it is. Okay, cool. So now let's see with progress bar. So I just want to be able to see how long this is going to take. And then I'm going to, oh, and we also can just, we already know. So we already know that we're going to be just using temperature. So I'm kind of like, I'm trying to wrap this up, gotta get out of here. I've got the double indexing thing, and that's because I'm passing it a list, and maybe it would be more, like you could do that just to make it a little bit clearer. The reason I'm doing that is I don't want to convert the data set into a data array by indexing a single variable. So this is a little hack. Just keep an inner bracket on that, and it will keep it a data set. And then you will keep it that way. And I do that because internally, remember, in data.py, we need to be able to index it on a variable. So if it's a data array, it won't be able, you can't index it that way. So let's go ahead and get this going. I hope this prints out. I haven't ever gone back and totally debugged. Oh, well, that was... It must not have actually loaded it. Oh, okay, maybe I need to... It's got to be that. It just hadn't calculated anything. There we go. Okay, so I'm gonna see how long this is gonna take. This might be a bit. Okay, we're creeping up. I'll go ahead and pause it still, because this is probably a couple minutes. Well, I regret to inform you, I think I got kicked out or something. I'm not quite sure. So what I think we're gonna try and do. I'm gonna look at DS. I'm gonna add a date selector here. So we'll use 1 year for. Yeah, let's just get it going like that. I mean, I got it about halfway. So, time equals slice. I'm gonna go 2016 because I see it doesn't have a full year there. And then 2016 through, if I want to grab, let's grab 4 years, 2020. Okay. Let's see. Now let's see if this works. It's roughly half the amount of data, so hopefully they let me get it through here. Check on HTOP while I do this. Just like to follow along, see how my compute is doing. So it cranks on a lot of them. That's not too bad. I'm going to pause it. Hopefully it'll not error out on me. We'll see. Heck yeah, we got it done. Okay, so now, yeah, so not very much. It's not a huge data set. Do want to look at it though. But we've still got 1,800 time steps. So we got 4 years. So let's let's break this apart, and maybe. So the thing that I'm noticing was my configuration was in the same cell as the thing that loaded the data, but what I really want is for it to be about here-ish. And then, okay, so I'm going to do 2 times 365, and then I'll do 365, and then I just want to double check, 1827, okay. 3 times 365. Okay, that means we actually have a lot more time. Does it pull? I'm a little bit confused why we have another 800. Is there some sort of duplication here? Day 1, day 2, day 3? No? Goes through, so it's, oh, I think I pulled 1 more year than I even meant to. So that's good. That actually means that we won't go overboard. What I was a little bit worried about was how this data set handled leap days and things like that for if I needed to like calculate some offset for the test data set. But in this sense, I think we're fine. This should just work. Yeah. So let's just real quick before we jump into it. We're going to train on 730 time steps, validate on 365, and test on another 365. But these are all non-overlapping. So, good. Nothing crazy there. So that goes there now. I think we can probably wrap this into here. I'm just going to start putting a bunch of stuff together. So if as we maybe have to debug things, we have to run less cells. I like to keep myself nice and tidy, as you probably can tell. Well, not myself, but you know my code. I guess I care about that more. Anyhow, jokes aside, let's get this in here. Oop. I'm gonna get rid of that. We're doing local. We're not taking the big thing. It's a price we're paying for the convenience of my time. Let me get HTOP out here. It's slightly distracting. Okay. Now the next thing we got to do is fix this. And I know you probably were wondering if I was going to forget this. Guess not. Okay, so we got this going. I still want to just run it on a single sample, just because because it's all loaded, this should run fast now. Oh, no, I don't want to do that. Right, you gotta make sure you run. When you merge the cells, you gotta remember to go ahead and actually do it. Oh, see, and I was wrong about how that progress bar thing worked. That's fine. We'll just get rid of it on the internal side. So this one we're gonna get rid of. No, not that one. This one we're gonna get rid of. We actually don't need the enumerate anymore either. Nice, simple. Okay. Just to verify, we didn't break anything. Excellent. I didn't ever set the model seed, so this is a little bit different. One thing I am noticing is a lot of this, and I should add some labels. I do note that we're getting some little ringing here. I think that's going to go away. Normally you'd fix that with like changing the momentum of the optimizer or something like that, or just lowering the learning rate. Anyhow, when we go to the full thing, let's get rid of this. Oh, see, but that's why I wanted that TQDM in there. I'm going to keep it for a second just because I want you to see how this works out. Okay, it's going to be ugly. There's a way that you can get it so that this doesn't... oh, you know what? I'm pretty sure. Let's go back to this. Training. Let's see. Did I do it the right way in this? I don't think I did because it was fairly simple. No, I didn't. Okay. Well, we'll get there. Okay. Oh, see, I'm going to have to wait another minute. I'm also going to have to fix my syntax somewhere. Oh, because this now needs to have TQDM. All right, I'm going to pause while this does its thing. All right, and we're back. Data loaded, running the model. Now you can see, check this out. We got all those batches in there. So it's going to take a minute-ish. Let's log into NVTop, see how my GPU is doing. It's like doing nothing. Wow. CPUs are doing everything. Did I not? The model is on the... Right? Must just be so small. Maybe that's it. Maybe it's too small. Okay, that's something. Let's interrupt this. Let's hit that batch size. 256 maybe? we only had 90 batches. We're going to go full batch training, I guess. See if we can do it. Oh, right, that was the number of batches, not the number of... Okay. Well, yeah, we're ticking up. Okay, now we're actually using the GPU. Cranking it a little bit. It's a bit faster. Still spending most of its time collating the data, it seems like. Yeah. I think it's, okay, so, yeah, so I'm pretty sure, and I can, yeah, so it's doing this too often, I think. I think that's what it's doing too often. So let's go ahead and we can make one nice optimization here. This is obviously, see, I'll just let that keep running while I code. So it's if I'm not even making an option. It's just, that's just how it's going to be. Wait, yeah. If self.preload. Okay, that's just going to make sure that doesn't. In the event that we had a lazy data set, you maybe wouldn't want to calculate that. So here we go. Okay, now we just need to do this. Simplifying. Right, we're just getting rid of the normalizing factor. Geez. All right, so in the meantime, I got this done. I restarted the kernel, and I've loaded in the data again. So now this should be significantly faster, I hope. It's got the data on there. Let's see what it does. Because it should be preloaded, pre-normalized, and all it's got to do is that. Not quite. No faster. I was wrong. Well, okay. So what I'm going to do, I'm going to pause it again, clean up some stuff, and then I'm going to, yeah, I'm going to do that, clean it up, see if I can get it to run a little bit faster, but then I'll come back to you. All right, so back. I did a couple little things. It's still not perfect, but this is a decent first pass. I mean, now you can see that the GPU is being used a little bit more often. Two things I did. First time I screwed up and had a bug in this preload thing, so it wasn't actually working. My bad there, but I got that fixed. And the other thing that I did that probably doesn't make much of a difference is I'm using pin memory, which basically just reserves the memory on the GPU, or something similar to that. I think it's been a while since I've read the docs, but basically it means you're not needing to go and allocate memory on the GPU every time. Not super important. But check this out. We're at about 30 seconds per epoch here. That's for both train and validation, so not bad. I'm just going to let it go. You know, it's got like, I don't know, like 5 more minutes I'm going to give it. So I'll go ahead and pause this and then come back and we can see how the model looks in a moment. All right, so we're done. We trained it. Let's see what it does. Hey, nice. This is great. The model definitely trained. Let's just... put on a log scale there just to, I don't know, sometimes I like to squish up the end there. But yeah, this looks good. This looks normal. We ended up with a lower validation loss than original. And now is where you would, you know, maybe do some hyperparameter tuning or whatever, but we're at that amount of time. So what we're going to do next is let's see how this looks. Let's put it on the test. So how do we do this? we got our test DS, and we're gonna need to normally, I highly recommend that you don't do this in the same notebook, but I don't want to get into the whole model saving and all of that. So we're just going to use the model that we just trained here. Test D. Now I can do for x comma y. And I'm just going to kind of roll this all in myself. Y creds. What's this? And test D. So this is just running one sample at a time now. No big deal. We're going to do with torch.noGrad x dot to device y hat. And I'm going to bring it all the way back to NumPy right away. And just for the sake of watching something. Okay, we do so. What's it? What's it trying to tell me? Oh. Okay. But, oh. Something went wrong. I didn't like that last one. Huh. Let's just do try. I'm not going to debug this at the moment. I think it's that it's something to do with the length of the data. Try. I think that's gonna. Yeah. So okay, it's. Whoop. Is test D on the wrong thing? Oh, we may have made a mistake. Interrupt. Whew, something's wrong here. Crazy. Yeah, it does not have that many samples. Let me. All right, I gotta pause and think about this. All right, so I think I know what the deal is, and I think there's going to be a easy workaround. I think this thing just isn't the GFS data set maybe just doesn't automatically know its length when you do just data set. I'm not sure. Usually I use what's called an iterable data set. Yeah. And that one you explicitly write how it works in a for loop. I didn't do that because I don't know why. So I think that's maybe just what's going on. So I'm just going to do for I in and okay, so we'll just explicitly do that. I think that should fix it. Yeah, there we go. Okay. Not so hard. And then mp dot. Oh, I didn't think about this. We are predicting 2 time steps. So I'm just gonna, for the sake of this tutorial, we're just gonna switch it over to like just looking at one of the time steps because I just want to get a view of this. Okay, so we've got all our predictions here. Now I've got test DS, and I could do something like 50, whatever, we'll see. Dot plot dot image show. Where I can do this, I can make that map. I want to be able to make the same map. So what I'm going to do is, and ypreds shape is not quite. Okay. Okay. So no, just a couple small bookkeeping things. Latitudes and longitudes make sense here. I didn't quite calculate the perfect number of samples, but that's fine. This is all stuff that's bookkeeping that you clean up. But what I want to do then is testds.icell time slice from 0 to the length of right. So that one will give me this. Okay, so that's going to be what we're going to really work with. So I'm going to call this TDS for now. And then I'm also going to do YDS. And that I'm going to do TDS.copy and then YDS of temperature 2M of colon or dot values of colon equals ypreds. So I'm just putting the ypreds into a thing that looks like an X-ray, or that is an X-ray data set. So now YDS, you can see, and I hope it is. Okay, so now if I do YDS of temperature 2M, and then I do icell times 50, dot plot dot show. Let's see how we did. Nope, I did a cell now. Need to do an index select there. Okay, and so this is the prediction that we got. Note the color scale is off because we haven't renormalized the data, so or unscaled it rather. But this looks pretty dang good, right? Like that's generally about right. Let's see if we do 150 to get a summer, I guess. And if I do that over here. That's also not too bad. It's a little blurrier, of course. We didn't use a super complicated model. We didn't do any hyperparameter tuning. It kind of captures the mean field. It's not a super hard task, but not bad. Okay, so let's rescale this. YDS and we want to pull. What was this guy called? Right, so we just want to undo this right here. So I'm going to multiply by the range. And then I'm going to, right, we're going to go, and then I'm going to add the mean. Okay, so let's get the range in there. Well, let's see this first, so it just didn't yell at me. We're working with test d dot mean. Okay. Test d dot max. All right. Now our scale should be the same. Uh-oh. I've done something wrong. Oh, this needs to be TDS, not TestDS. Right. That actually might be, oh, see, I guess I didn't consider that fact. We'll do the same thing for TDS. Okay, so now we're back in physical Celsius space. Gotta watch. The thing that was going on was basically the reference to the data sets in here are persistent, so it actually ran when I run it in here, it actually affects the data sets that were out there. So it's one thing to be aware of. also a little bit skeptical. I think I might have. I'm gonna guess I did something dumb here. Yeah, I've done something wrong. I missed it. I think this first copy wasn't right. Okay, so let's redo that. Oh, that's gonna redo the model. Okay, well, anyway, let's make this. Okay. I'm gonna go back. I'm gonna rerun everything. It's gonna take a couple minutes, so I'll be right back. All right, got her figured out. I just need to restart and redo everything. Of course, it was the scaling being applied to the original data with sort of a bad copying. So, what do we got here? This shows pretty good agreement, and I actually think this is also shifted by one because the predictions I made were actually 1 day ahead. So you could even shift this over a little bit, but you can see there's a solid match on these dynamics, which is awesome to see, and of course the spatial maps as we already saw. So the actual GFS data has, I don't know, a little bit more fidelity, I would say. You know, especially like the mountains here, you can kind of see, get a little smoothed out over here, but overall, solid performance. So that's where I'm going to end this. I'll make sure to make all of this code available. I'll clean up a couple little things, but you know, this is end-to-end how you train an image-to-image regression model with a ResNet. All right, cool. See ya.